Hello, everyone, and welcome to the Physics 121 concept session on calculating an instantaneous acceleration. My name is Nathan Martin, and I work for the tutoring centers at ASU. So, this problem we're given, the function below gives the displacement of a particle at time t in seconds. Find a function for the instantaneous acceleration. Also, compute the instantaneous acceleration at 5 seconds. So we're given a displacement, right? And essentially we know that the acceleration, right? The acceleration is equal to the rate of change of the velocity with respect to time, right? So it's the derivative of the velocity equation. But we're not given the velocity equation, right? We're given the displacement function, right? So velocity, the velocity is just the derivative with respect to time of the displacement function. So in other words, our acceleration is equal to the second derivative of the displacement function. Right, so what we have to do is first calculate the velocity, right? So we know the velocity is equal to the derivative with respect to time of the displacement, which is t squared plus 3t minus 10. So the velocity at any time t is equal to, now we just have to take the derivative of each term. If you remember back in your Calc 1 days, or if you're taking that now, I know that the derivative with respect to time of t squared, I would use the power rule, right? So the derivative of t squared, I'd bring that 2 down, so it'd become 2t. The derivative of 3t is a positive 3, and the derivative of a constant, negative 10, is 0. So I'm not going to include that. So cool, that's the velocity, right? But we don't want the velocity. We want the acceleration. So the acceleration, we have to take the derivative one more time. So it's the derivative of the velocity, which is 2t plus 3. So the acceleration at time t, what's the derivative of 2t? That's just 2. What's the derivative of 3? A constant. Derivative of any constant is 0. So we're not going to include that. So there we have it. The acceleration as a function of t is equal to 2. So in other words, our acceleration is a constant. So now we want to compute the acceleration at t is equal to 5 seconds, right? So the acceleration at 5 seconds, well, we have nowhere to put a t in, right? Because it's a function of time, but since it's a constant, it doesn't matter what the value of t is because it'll always equal 2. And it's 2 meters per second squared, right? The units of an acceleration is distance over time squared, meters per second squared. Awesome. So moral of the story, instantaneous acceleration is the second derivative of your displacement or the first derivative of your velocity. Same thing. Awesome. So let's clear that up and talk about some tutoring services. So if you want more information on tutoring, such as hours of operation, location, any review sessions we're holding, visit our website at tutoring.asu.edu. And then if you want to watch more of these concept videos or whatnot, visit this link at tutoring.asu.edu/student-services/reviews. Thank you all for watching, and we'll see you in the next video.